Hey everybody, this is Eric Andelin. I'm a senior solutions consultant here with Kittyhawk, and I wanted to give everybody an opportunity to see what we have in air control with regard to automated missions and flight planning, where that may help you in your enterprise. I know a lot of you have grown beyond just one or two drones and, small scale operation into something that's much larger where some of the features of air control really benefit you. One of those is being able to create automated flight plans within the desktop environment, save those flight plans, and then make them available to folks out in the field. If you've got an operation where you're in Dallas and you've got teams working on projects in Florida and in Utah, this is very beneficial, especially if maybe those folks are, 107 pilots, but their primary role is survey crew or, field advisor, something like that. You can build these flight plans for your mapping missions that meet your guidelines and your standards, and then again, once you save those, they become available to that pilot in the field. Once that pilot logs into air control, those flight plans now become available, and they can select and load a flight plan, and then from there, it's a simple play and stop button. So they can launch it by pushing the go button. The drone will take off to complete its mission. At any time, of course, they can abort that mission, they can stop the flight, they can go offline, they can restart that flight, all those things. So they still have full control over your drone as it's in the air, but they have the benefit of those automated missions. So we're going to have the chat window open. I'm going to try to concentrate on getting through this. But we will be asking questions. You are welcome to ask us questions. And at the end of this, again, it's free for all. Ask all the questions you want. I am wearing my new Kittyhawk swag, so I don't have a screen behind me because this is green, and if I had a green screen behind me, I would just be me. So anyhow, I believe you're seeing my screen. And we'll go over some of the basics of creating flight plans and automated missions. So you're familiar with, or you may not be familiar with air control, but we've really streamlined things, made things look a little better and more useful. So let's look at a couple of things that we can do with air control and automated missions. If you think about it, when you're creating missions, whether it's in Kittyhawk or any other program, what you're doing is you're sending a string of commands to the drone. And so here, we break that down so that you can actually create those commands as you need them. So, some basic things, I can show you this one. Let's create a new plan. I'm in Tampa, so it's loaded in the area that I'm in. So let's create a new plan, and this will just be a flight. So we'll go new plan as the internet gives. It's going to ask you to pick a takeoff location. So let's go over here. Let's see. Set a takeoff location over here. Okay, and then we'll give it a temporary name. With that name. And then you have options when you're creating your flight plan. So takeoff restrictions, and you'll see this here in a second. A takeoff restriction is, you'll be familiar with this if you've worked with DJI for a long time. In the past, if you created a mission and the pilot wasn't in that area, or the pilot had left that area, gone on to another job, and he loaded a mission, and maybe that mission was the previous one, the drone would take off and head to that mission, and you may never see it again. You've all heard about that. So we set a takeoff restriction, and if you say specific area, it's going to give you a little 20-meter circle, and it's going to say, if the drone is in here, we can take off. If the drone is not in here, you need to get in that area before you can take off. So it gives you a basic template. It starts with that. So we'll go with that, and I'll show you how we can adjust that. Action on finish. So again, we're stringing commands to the drone. So what do we want it to do when it completes an action? In this case, I tend to like to fly home and get a little bit of time on the sticks when I'm working with these. So you usually put none. That also applies if you're going to string more commands together for it. You do have the option of return to home, and it will return to home. And then you have the option of auto land, which means it's going to land right after it completes that task. Okay, so we'll go ahead and we'll leave it at none. You can set your parameters for speed, descent, all of that. And then you can add some automatic features here as well, but we don't need those at the moment, so we'll skip that for a second. So then it gives you a handful of template options. Are you just flying to a destination? Or are you going to map a facade? So you could map the side of a building, you could map all the way around a building, those type of things. Then you've got your typical grid-based map. So you would use this to, for example, create your orthophotos. Also, if you were on the first responder side and you were doing search and rescue, you would use this as well. You would just create your lawnmower pattern over an area that you wanted to do search and rescue, and it would follow that path. You can also ask it to do an orbit. So some people that are getting a little bit more intricate with their mapping, especially if they're doing 3D work, they may want to map it as a lawnmower pattern and then turn around and do some orbits of that same area to capture the sides of facades and things like that. And then you also have path. So these are the basic templates, and we can expand from these, but I'll just show you one real quick. So we'll just say we want to do an orbit. So right now, don't worry about where these features are at the moment. They're just kind of in a basic area. But let's select a location for an orbit. So I want to orbit this house right here. I can set the altitude that I want to orbit at. I can set the takeoff location, the reference. Okay, so if you're familiar with like a DJI drone, where it sits when it starts is basically 0. Which is great if you're in Florida or the fields of Kansas and you have no elevation to worry about. You're good to go. For the rest of us, you might want to use ground. So ground will take the SRTM surface that's standard available throughout the US, and it'll pull that elevation and it'll use that as ground. This is what you want for terrain following. So I typically reference ground no matter what. And then you could also reference mean sea level, which would work for me here in Florida, but not necessarily for everybody else. Okay. You're going to then select the final altitude. So if you did that as it was rotating, it would spiral up or spiral down. You can set your radius. So I want to set my radius at, I'll leave it at 100. And I'll leave the final radius the same. I want it to go clockwise, and say I wanted to go clockwise 3 times around this building. So 3 rotations. Okay, and it'll give me a 1080 circumference. So we're good there. It'll ask me the drone heading. So right now, the drone is facing the center of the circle. I can also add a gimbal orientation, but the gimbal orientation here is default at 45 degrees. You can see it there at 45 degrees, and it's referencing the horizon, which is what I want. I want it to look down on this point of interest. So I'll go ahead and finish that. And so it's created that flight plan for me. Now, it didn't necessarily know where I was taking off from, so I will go ahead and move this location because I know from paddleboarding around this area, the only thing in that bay is sharks. I don't want to be there. So here you go. I'm setting my takeoff location to this intersection. And I mentioned earlier that you've got a takeoff restriction. If the pilot sets up here, it's not going to take off. So what we can do is we can expand that area. So I'm going to expand that area. It gives the pilot a little bit more leeway as to where he can take off. and then it's going to take off from here, going to go to this point at 100 feet, and then it's going to start circling this area, looking straight down. Now, I'll probably have a Mavic Enterprise with a microphone so that I can let Tom Brady know that the Kansas City Chiefs are going to beat him in the Super Bowl this year. I think we all agree on that. Okay, so that's basically how you would create a quick little mission. And we've got a couple other features here that are pretty nice that you can see. For example, if we want to look at an estimate of time, this is going to tell me how long it's going to spend in the air on this flight. And you can see, I didn't have the camera turned on. I didn't have the video turned on. What I would be seeing here is the live stream. So I'll go ahead and dismiss that. If I wanted to keep this mission, all I would do is go up here and say save flight plan, give it a name, and then I would save that flight plan. As soon as I did that, field operators could then log in and see that in the field. I'm going to go ahead and delete this one. That's just an example. And it'll say that that flight plan is gone. So let's make it a little bit more challenging. Let's create that same flight plan, but let's map this area. So we'll go create new flight plan, select the takeoff location. Again, I'll say here. And we'll call it test mission. Give it a name. Oops. We have that. And I'll again say specific area. Action on finish, I'm going to say none, and I'll show you why. We'll leave the speed and everything the same. I'll go ahead and hit next. I'm going to tell it I want to map this area. So it's going to say, give me a rough location for the map. So I'll go ahead and drop a point here. Gotcha. Come on. Here we go. So it's created a basic template of that area. And the first thing it's going to do is ask me what drone I am flying, because of course each drone has a different sensor on it, and that sensor determines what your overlap and your side lap are so that you can create your map. So typically I fly a Mavic Pro, so I'll put that down there as Mavic Pro. It will change it to Mavic Pro. And then maybe I want to fly at an altitude of 100 feet. Again, I'm going to reference ground. Not so important here on Davis Island where it's flat, but important in other places. And then I have the option of what kind of pattern do I want to fly this out. I'm going to say I want a grid pattern. That way I can attack it from both directions and get, a nice, dense, overlapping mapping area. So it's going to adjust to that. Speed is set at 20. You could slow that down or speed it up. Some folks like to put a little bit of angle in their capture so they capture a little bit more of the sides of the buildings. I'm a traditional mapper. I wouldn't do that, but it's possible. You can also go from capture mode. You can go from photo to video, your choice, and then it defaults to a capture interval. So let's go ahead and accept that. And as you can see, it's created this basic grid around the area that I'm working. I don't need to map an area that big, so I'm just going to resize it by grabbing the corners of the image, or the mapping limits. Pick that area really nicely, zoom in, make sure I get a nice look at that property. Okay, I'll zoom in a little bit. And again, takeoff location was just a general area. We'll move it over here. And I will again expand that radius so that the pilot's got more room to work with. And now we have a mapping mission that's going to cover this area. I can, if you want to tweak the direction of the flight path, you can just grab your entry point and move it to how you would like it to be. So let's say I want it to look, more universal like that. So all it's going to do is make some adjustments, and we'll have that mapping area. So what it's going to do is it's going to take off, it's going to fly to the entry point, and then it's going to start collecting its missions. And again, we can look at this by time. So it's going to say 8 minutes, 166 photos. I'll dismiss that. You can do a couple other things too. We have map layers here that you can turn on and off. So if the area gets confusing or crowded, go ahead and turn those off. So for example, if I say all off, all the map layers are gone. If I want to see just the flight path, there it is. If I want to see the path segments or waypoints, markers, I can add all of those in, boundary points. Here we go. So that's the border of the area that we're flying. But turn the flight path back on. So you have all of these things that you can turn on and off. So we'll just turn them all back on. I know what I'm looking for here. I also have this icon right here in the middle. If for some reason, maybe I'm mapping the wrong house. Uh-oh, I did the wrong one. I could grab this and pull the whole thing down here to the area that I want it to be in. So you've got a little bit of flexibility there with your mapping area. So it's going to fly this mission, and it's going to end right here on this mark. And I told it to do nothing once it finished that. So what I'm going to do is I'm going to add a component to that. As I mentioned before, we can now add more to this. And since I'm going to model this house, by the way, this is Derek Jeter's house, since Tom Brady's living in it, since I'm going to model this house, let's go ahead and capture a little bit more detail here. So let's add a component to this. Let's go ahead and add an orbit. So now it's going to ask me, where do I want the orbit? I'll just say right in this area. And let's give it a second to catch up. And it's going to ask me again, what do I want the radius of the orbit to be? What altitude do I want it to be at? I'm referencing ground elevation again. I'm going to say the radius, let's make it 150. And clockwise, we're good there. I'll say done. So now I can grab that and I can adjust it a little bit. But let's say I want it right in there. So now once it completes the mapping mission, it's going to go ahead and do the orbit mission and collect data then. It's going to do one revolution, and then again, it's going to stop. From there, I can take it over and land, or I can have it return. So if in my case, I would typically take it over and land from there. So it's gone ahead and it's recalculated everything for us, and now it said it's 10 minutes of flying. So there you go. And you've got the ability to do that kind of mapping. So let's look at a few other ones. Again, if I save this right here, if I save it, it's listed as test mission. I could give it a name. If I open it up, I can rename that mission. I don't need to change anything there. But if I go up here and change that name, done. I save. Forget. So now I've got it, it's stored, and if pilot wants to take it and go from there, they can. So let's look at some other things here. In a lot of cases, you're going to get a mapping limit from a client, or you're going to get a mapping limit from your construction supervisor in the field that says, hey, I need this area mapped. As long as we have a KML, we can do that. So let's go ahead and we'll look at importing flight plans. I'll move this over. And let's import a flight plan. So let's go import. And actually, this is going to import a boundary. You could also import a flight plan, but we're looking at importing boundaries here. So client sends me a boundary. As long as it's a KML, again, you can import that boundary. Go ahead and hit open. And then it's going to ask me one question, really. It's going to show you that you're importing a polygon, and this will be in light gray. If there was nothing there, then it would be saying there's a problem. I don't know what I'm importing here. But again, we have options here. Do not import destination, orbit, path, map, facade. So let's go with just import a map. And it's going to do a couple of default actions for you here. Okay, as it imports that map. Okay, so what it's done is it's gone ahead and imported a default map. So what we're going to do is we're going to make some adjustments here. The first thing is I can see that it's giving us a warning. And it's giving us a warning because it doesn't have a specified takeoff location, which is fine. You could launch your drone, you could fly it around. Say, for example, you have a LiDAR unit on that drone and you have to wake up that IMU. You're going to launch it yourself. You're going to run it through some maneuvers to wake up that IMU, and then you're going to load that mission and hit play. It's going to go to point 1, and it's going to fly that mission. In this case, though, it's asking me for a ground elevation to start with. Again, since we're over flat terrain, the ground elevation doesn't matter, so I could have gone with it. But let's go ahead and just say view. And what it's going to do is it's going to set that point for me. So now I'm going to say take off from a specific area, and the action on finish I'll leave at, we'll change that to return to home. The speed I can change. Bear with me as the action on finish catches up. We'll change the speed to 20, and we'll say done. Okay, so now I have a takeoff location. You can see it's set that takeoff location over here. I'll just go ahead and move that. Oh, that's my boundary. Grab my location. Yeah, and we'll just move it out here into this field. And again, I've given myself quite a bit of area to work with on that takeoff. Okay, so it's showing us that we have a map built, and that map was just defaulted to a Phantom 4. So again, I'll say I'm working with a Mavic Pro. It set me in at 295 feet, which if you looked at the KML I imported, it actually was in meters and it was 90 meters. So it's about the right range. So let's go ahead and say I want to do it at 400 feet. Again, referencing ground level. We'll leave the pattern as normal. We leave everything else the same. Capture angle is negative 90 degrees, so nadir photos, and then it'll capture the photos. I'm going to go ahead and hit done. And we can take a look at it again. Here we have estimated time, so 9 minutes, 21 seconds. We have 114 photos. And then this is where it gets really fun. This is where I really think we've got a good product here, and this is what you should see. We can build mission previews of what the drone is going to do. So this is very important when you're sending data out to the field or missions out to the field for pilots to fly. You really want to make sure before this is saved and sent to them that it's going to complete the actions as it was told to do, so that as you scripted that action, you scripted it properly. It's not such a challenge when you're doing just something as simple as mapping, but then when you add that orbit in, or when you add fly to another path, things like that, it becomes a challenge. So what it's done here is it's pulled up a simulation mode in the upper right, kind of in a Google Earth view. And then it's given you a linear graph of the actions that it's going to take. So if we look at this, first I can grab this linear view and move it around. So I'll take that and I'll just do some adjustments to it so that we can see it a little bit better. That just gives us an idea of what it's going to do. If I wanted to, I could take this path and I could export it again out to a KML. So I went from a boundary that I imported to now I can take that flight path and export it to a KML as well. which some folks might want to send to their engineers or what have you to confirm that you're capturing the proper area. Okay, so it's got that sitting up here ready to go. And then here we have a linear graph that tells us what's going to happen. So this is the complete flight here. So at 400 feet, we're going to execute this mission with this much overlap, this much side lap. And then it gives me a rough acreage of that area. We also have the approach. So from the time it takes off to the time it goes to point 1, this is the action it's going to take headed to that approach. So it's going to go straight up to 400 feet and then head over. And then right below that, we have camera actions. So this is basically telling the camera to turn on, focus, and then to start capture. These are the actual exposure points right here. So you can walk through them and it'll name them off. And then also we have a gimbal command. The gimbal command right here says, okay, as it's flying to point 1, it's going to get there and it's going to turn the gimbal down to 90 degrees. And then the last thing it has is battery. And then below that, it has altitude. So it shows you, yes, it's going up to that altitude and it's going to complete that mission. So let's hit, first, let me turn on the capture points. We're going to toggle those on. Now you can see the actual exposure points, and they're all right here. So let's play this mission. And we have the benefit of speeding it up. So we'll go ahead and speed it up. But what you're seeing is the drone is taking off, and it's getting to altitude, and it's flying towards that location and getting ready to execute that mission. The magenta area that you're seeing is the field of view of the camera. So right now, the camera is pointed straight out into the horizon, and this is roughly what it's going to see as it goes out there. We have a slider bar right here, so I can grab that and I can advance the mission. So I'll move it up to here. And what interests me is I want to make sure that that camera is going to turn to nadir and start capturing those photos. So here it goes. It did. It turned to nadir, and now it's going through the capture modes. So again, the magenta area you can see is the area of coverage for the camera, and then you've got a simulation on the screen here as well showing you roughly what it's going to capture. The nice thing about this is that you can see, okay, yes, I'm going to have 3 lines of overlap for this mission. And so I've got 80% forward overlap, 70% side lap. That's going to give me probably 10 to 16 looks at every point in every image, which is what Pix4D or SimActive or Agisoft needs to create a precise model. So it's going to fly through the mission. So this is what we want to use when we're creating these missions and we're sending to folks out in the field, because we want to make sure that we're capturing things properly and that what they're going to fly is what needs to be captured. So I'll go ahead and stop this, but this is basic understanding of how we're going to do that, and then again, use that to our advantage to make sure we know what we're capturing. Let me stop that. Now, we also have another feature in here that's really important to me because a lot of my mapping projects in the past were landfills, things like that, where we've got terrain, rock slides, so forth. So let's look at the terrain capabilities of this. I will close this window, open this one. So here we have, again, this is actually a landfill. It's just a little bit farther south than where we were. I can zoom out a little bit. Oops. So here we have a landfill just south of Denver. You can see the Raceway Park up there in the corner. And this would be, a typical, again, mapping mission. We're at 400 feet. Look at that real quick. We're using a Phantom 4 Pro, 400 feet, referencing ground level, a normal pattern. We have all that information in here. And we've got the time estimate here. I'm going to look at the time estimate really quick. I want to make sure if I'm flying a Phantom 4 Pro that I'm not going much over 30 minutes because I don't want that to affect the battery. Doing those calculations for us. Oops. I got a little pushy there. doing those calculations for us. It'll give us an idea what that mission estimate is, but I believe it is like 28 minutes. Yep, 28 minutes, 340 exposures. So I'll go ahead and dismiss that. And I went ahead and put this into the mission preview as well. I did this earlier just for effective time so that we have it here. But what I really want you to see again is we're referencing ground. So it's pulling that local elevation model, and it is now terrain following, not just flying. So you can see here on the map, we actually have the drone following the terrain, which is very beneficial when you're working in elevation, because if you set that at, say, 400 feet and you flew 80-60 overlap over that whole project, you're going to end up with much smaller footprints than you up here than you will down here, and that can wreak havoc on your software that's processing your mapping data. So we have that, we can see it, and we can verify it. And again, if we run the mission, we've got our linear table. It's telling us what's going on here, what the camera's doing as it's taking those photos. I'll just go ahead and run it, and I'll 4x it as well. So it's going off to execute its mission. And again, we can toggle those exposure points. We'll hit that and toggle all those. And it'll take a second for those to populate. And we have our features down here. And the big one to look at here now is, again, the elevation change. So as the drone is flying, it is actually following the terrain. It is maintaining that altitude over the course of the mission, which is going to make your data set much cleaner when you go to process that data set. Another feature here, if we go just up a little bit, you can adjust your battery time. So this one has a 30-minute duration. If I was concerned about my batteries or something like that, I could set it to 25 or 15 or whatever I want. And then you could manage that as well. So as it goes through its mission, you can see, I'll just move it a little bit. There's our exposure points. We can zoom in a little bit. And we're getting a decent amount of collection. Of course, as you can see, I changed the overlap to 80-60 here. Overlap is always your preference. More is always better, but more is also a lot more data, and it takes a lot more processing time. So you have to, figure that one out for yourself. But anyhow, that's what that looks like. And then I wanted to show you one more feature. It really has to do more with our scripting capabilities within Air Control and our Mission Planner. And that is the ability to create panos. Fix this. So I mentioned before that you can import flight plans. So you can manually create these. Once you create them, you can save them out and then bring them back in later. And then you can also move its location. So for example, I'll show you a pano mission that I created. And we'll go ahead and import that. And it is right here. So we have a pano mission, so it's going to fly 54 exposures at different cardinal directions and at different gimbal pitches to capture an entire scene, and then we generate a pano with that. And as you can see, there's 139 components related to this. So let's go ahead and import it. And this is a pretty simple one. So over here in the area where I live, this was an empty lot. Now it's a house. This is my launch point. I'm going to fly over to this intersection where everything's under construction here, and then I'm going to create a pano of this area. And if you look at the command list that's involved here, it looks something like this. Fly to the destination, that's straightforward. You're telling it where to go. Nothing challenging there. Once it gets there, here's what we're going to do. So let's tell it what we're going to do. And then as I expanded that, you can see. First thing it's going to do is set the camera focus mode to auto. The second thing it's going to do is set the metering. I want it to meter the whole scene, not just a small area, because I'm looking out into the horizon. So we're going to meter as much of the scene as we can. And then I'm telling it, okay, you're going to turn and face this direction with a gimbal angle of this and take an exposure. And you can see that here if I click on this. So it's going to say gimbal orientation, pitch 20, start capture. That's frame 1. We're going to do this 54 times. So you can see as you build these commands, it's nice to be able to save them and use them as components somewhere else. You can also say, send me an email and say, hey, Eric, I really need that pano. And I can export the mission, send it to you. You can have it and do whatever you want with it. So that's a nice thing. You can share this stuff amongst each other if you want. So as we go through, all it's doing is at each frame, it's going to adjust its direction, and at each row, it's going to adjust the gimbal pitch, and then at the end, it's going to wait, and it's going to come back. So if I do a quick mission preview in here, it's going to tell you it's going to take 8 minutes and 14 seconds. It's going to capture 54 photos. And if I run the mission preview, and this is, again, when you're building something as complex as this, you certainly want to run that mission preview so that you get a good understanding of what it's going to do. So let's let it create the preview. And here we go. And then again, now you can see a lot of information going on down on here that you want to verify that is correct. So let's let it load up, and I will let it start the mission. We'll go ahead and run it. It'll catch up to us. And we'll go right to the good stuff. So as the camera gets online and to its location, you can see it's looking out into the horizon as it's taking those photos. And I put a decent amount of wait time between exposures because I really want it to get the correct lighting and settle itself in before it takes that exposure and moves on to the next site. So let's go ahead and speed that up a bit. And you can see it's taking those exposures at different rates in different directions. See that with the magenta, so we're good. And then if I move forward here a little bit, you can see that the gimbal pitch has changed, or the orientation. And if I move forward a bit again, you can see that that orientation has changed even more. And we run through it just like so. So now you can take these 54 images and you can run them through your favorite pano tool, just like you would take your mapping imagery into SimActive or to Agisoft and let it run the mapping. You can do the same thing in your favorite pano tool, and you will get something like this. I'll go ahead and stop this. So this is one of the panos that was created from these 54 images, and I'll zoom into it, or I'll create the pano, turn it on, and you can see it's a lovely day in Tampa Bay, or it was in May. And this is the construction site I was looking at. So we're getting a bunch of new apartments and a bunch of new college students. And this is the street that is torn up in our neighborhood and what the progress might be like. We have that ability there. And we can look at one that's a little bit more recent. So this is more towards project completion, at least on our street. And we'll let this clean up a bit. This is lovely downtown Tampa, where right now the Stanley Cup exists. And you can see the construction on the nice apartment complex and our nice new beautiful street. So we have the ability to capture imagery for these purposes as well. I hope I didn't make you all dizzy with that one. And then one more I've got time to show you. Remember that your drone is, I mean, you have a payload and you have a drone. And the drone is the thing that flies for a duration of time, and the payload is what captures, the imagery or the data that you want below it. So we do have the ability, people have asked, can you fly LiDAR? Yes, you can. Most LiDAR systems that I'm aware of, except for maybe the new DJI one, operate independent of the drone itself. So by that I mean when you operate a LiDAR system with a drone, you're turning that LiDAR system on before the drone takes off, and then you're turning it off after it lands. It's collecting data separately. So we can look at, for example, see if I can find a LiDAR. Actually, I can switch. Let me switch to one. I'll go ahead and switch out of this account, and I'll just go into another trial account so you can see this. Go. And I'll go into flight planning, and we'll look at So this is an interesting one. This is a LiDAR mission of a active highway. So let me turn some things off so it's easier to see what's here. Go ahead and we'll turn them all off. And then we'll just turn the path, flight path right here. So what the intent was is to take off in this area. So we'll turn on the restriction zones and the takeoff pin. So they wanted a big zone to take off from because you never know what's going to be happening in the parking lot, but that's roughly the area the takeoff's going to occur. And as I said, you're going to have to get the IMU up in the air and wake it up before you come online and execute your mission. So in this case, they're going to take off, get that IMU active up here somewhere. We don't want them going over here with the IMU and then starting the mission, because if they do that, no mission will start. So we want to give them a big area to work with. They're going to shake up the IMU right in here. Then they're going to execute the mission. And what they wanted it to do was they wanted the ability to pause that mission before they crossed any highways or any roadways or anything like that. So take off, it's going to come to this point. It's going to fly this path all the way down to this railroad crossing here, and then it's going to stop. And you can see right here, it's waiting for a command to continue. Because even though we're way within line of sight, still you have an orientation issue as you look up. So rather than you stopping it yourself, let's let it stop at the planned position and wait for the next move. So as it stops at that planned position, maybe someone is a visual observer on the highway, is tracking what's going on. They're doing this on a Sunday morning, it's church, there's nobody out there. But they're going to give that execution, go ahead and continue to cross the road and then execute the mission. So we created a couple pause points in these missions so that they could control that. And if we look at that in mission preview, really the only difference here is that it's flying a mission. It doesn't care whether there's a payload underneath it or not. And with IMU, you have that with LiDAR, it's running anyway. So all it really has to do is fly a path. So that's what we're having it do here. Creating that preview. There's not going to be much to see other than it flying a path. So that might be too much detail here. We'll let it finish. And keep in mind, as you're working with these, if you're in the field and you have a laptop, of course, you can open up your laptop and you can work with these and adjust them and what have you. But here's another little hint. If you're in the field and you have your iPad and that is what you're using, you can go into this through Chrome, and if you just select the 3 buttons in the upper right corner, then you can convert Chrome on your iPad to desktop mode. Once you're in desktop mode, you can again go in here and edit these all you want. So that's a little tip when people ask, can I edit in Android or can I edit in Apple? Yes, you can. You can do that. So here it is showing the mission, and again, what I want to look at are, is it going to stop at these points and wait for a command to go? If you're looking at this on the app as you're executing as a pilot, it literally just stops being a play button and starts being a pause button. And as soon as you hit that pause button again, it starts to play, the mission starts to execute again. So you have that capability as well. It really, the nice thing about air control is if you can think it up, you can probably write the program or the routine to have it execute that mission. And as a group of users here, we can all discuss this and help each other out and go through some of the pain points that we've been through if we have any. But you can certainly create pretty robust missions. In this case, I think we had terrain following on. Now, you're not going to see the gimbal position change necessarily. Let's see if we've got one in here. Yeah, it's just staying at 0. And the reason for that, again, is it's a LiDAR unit underneath it. We're not controlling that. It's just been turned on, and it'll be turned off. Now, depending on whether you're using a yellow scan or a Regal or something else, you're going to determine what your swath width needs to be for that. That's something that you would have to come up with. But pretty basic stuff as far as this goes. And honestly, with that, that's pretty much all I have. So let's open it up to questions. And I'll be more than happy to answer anything I can and share with you any more that if you guys have any questions, let's look at it. So I will go ahead and stop sharing this. Well, I'll leave the screen on in case you have some questions, but let's go ahead. Erica, you can help me out here, or we can go through the chats.
Yeah, so there in the Q&A box, looks like there's a question, what is a KML?
Oh, okay, so KML, that's basically a Google Earth line file. And Google is answering the question as well. So let's look at Google Earth. So this is Google Earth. We all have this. This is free and downloadable. KML really stands for Keyhole Markup Language. Keyhole was the predecessor to Google Earth. So they just kept the name. But all you do in Google Earth is you go ahead and create a polygon. We'll just give it my name. You give it a color, a style. You give it an altitude. You're always going to want to give it an altitude. If you just leave it at ground, it's going to be clamped to ground, and I'll show you what the difference looks like. If I do a clamp to ground, and we go to description, measurements, if I go over here and I draw a polygon, and it's clamped to ground, it's going to hold the shape of that surface. If I change that to relative to ground, and say I want, see, now it's digging into the ground because it's at 0. But if I change it to 200, it's going to raise off the ground and into the air. And you can easily take those and save them out and then import them into air control. The other popular format would be DXF or Esri shapefile. Those are more proprietary. You can take either one of those and convert them to KML. KML is a much more used delineator. similar to Esri shapefile, but KMLs go pretty much anywhere, and you can just import a KML that way. So that's what a KML file is.
Awesome. The next question we have is, will the terrain following and mapping do negative integers? Say one is mapping a valley and taking off above the area needed and needs to fly below the takeoff location.
Yes. Yes, it will. So if you're, say, for example, on a ridge line and you want to map across that valley and you're, say, running alongside a bridge or something like that, it'll actually go down. It'll follow the terrain down and follow the terrain back up. Yes.
Awesome. And that question was from Bradley Skeen, and he also had a follow-up question. Is there a maximum number of points for mapping?
I've not run into one. No, I mean, you can make the shape as jagged as you want. Your issue is going to be battery. You're going to run into a battery issue before you run into an issue with the point size of your mapping limits.
There's a follow-up question also about what happens mid-flight when the battery gets low.
So right now, at this very moment, we are one battery programs. So you're gonna break up your mission based on batteries, but we should have it in here pretty quick where it will reach a point where it's time to change the battery. It'll drop a place mark that it knows. It'll fly back to pick up, so you can reload, pick up another battery, and then it'll return to that point and continue the mission. We have a few more lines of code to add, but it will be there soon.
Gotcha. So that would answer the question of what happens if your flight plan is larger than what can be captured in a single flight then.
Right. Yeah. Now, you do have it from a precautionary point of view, you do have, when you create these mission previews, you do have some ability to check that. So again, in this case, the battery is set at 30 minutes. If I wanted to say, hey, I'm a little bit more leery about that, I want to keep my mission to 15 minutes, you can go ahead and make that adjustment. And it will adjust this bar down here so you can see how it's doing on that mission, and you can make that determination, hey, I don't have enough battery to complete this mission. Of course, you could also do that here in your mission preview. Knowing what your battery limitations are, you could let it calculate the time and say, okay, in this case, I got 6 minutes. I don't know what I'd have to be flying to only be able to fly 6 minutes. Probably something from Intel. So yes, you have some capability there to know whether or not you're going to exceed your limit, and we will have the ability to swap out batteries, but again, that's not there just yet. It should be there very soon.
Great. Questions about hardware. Is flight planning capable with the M600 series?
Yes.
Okay.
Yes. In fact, I personally went out and flew an M600 with a LiDAR unit underneath it probably about 3 weeks ago. And maybe a follow-up to that was, I've had people ask, does it track all 6 batteries on the 600 when in air control? And yes, it does. So when you're into the management side of air control, not necessarily the flight planning side, but it's tracking batteries as well.
Great. Next question. Did you say that you can set drone speed during the flight?
Yeah, well, you're going to set drone speed when you're creating your missions, not necessarily during flight. So you're not going to take over. If you do anything with the sticks during flight, you've paused the program. So you're not going to want to do that, but you can make those adjustments when you create the mission. So you may want to have it approach at, full speed, and then you may want to have it map at 13 miles an hour. You can make those adjustments when you create the mission.
Does the simulator have 3D buildings and 3D trees?
It does not have 3D buildings. At this time, we're looking into adding that. It really depends on the city and whether or not they capture that. Trees, not so much. And I would say, to go with that question, The surface model that we use, the surface model that is generally available in the US, does not contain information about trees or poles or radio towers, things like that. So you always, of course, have to be conscious of that.
Another question about Google Earth. It says, what happens if Google Earth changes when you get out and perform your mission? Will the drone pick up the changes since Google Earth is not in real time?
No, you're using, the imagery in the background of Google Earth is, only current to when they flew it. And depending on the city that you're in, or the urban area you're in, or the rural area you're in, depends on the cycle in which Google or Mapbox or whoever, Apple, if they're still doing it, captures the imagery. So no, we always say, an on-site visit from somebody before you make a determination to fly is very important. You don't necessarily want to trust Google Earth in areas where the environment's changing a lot.
Definitely. Next question. Can or will you be able to set a flight from your viewing device on site instead of having to make a flight plan on the computer prior to the flights?
Yes, you can still do that. And that's what I was saying you can do with, as long as you have access to Chrome, so you're going to need some kind of connection, cellular or wireless. As long as you have access to Chrome, you can access the flight planning tool just by going to the upper right, selecting those three dots, and hitting desktop version. Once you hit desktop version, you now have the ability to adjust or create flight plans.
Got it. Okay. Question, is there a mass cache feature inside Kittyhawk, such as caching a whole state, town, or city, or what is the limitation?
I know it's not mass caching, so I could not tell you what the exact limitation is. We could get back to the person who asked the question. That's a little bit beyond my pay grade.
Okay, sounds good. I'll put a note there. Question about weather. Are you considering the winds and icing situations during the flight plans?
We don't consider the winds and icing situations during the flight plans. This is considering it's a perfect day and you have that ability. Now, I will say that within Kittyhawk, when you're looking at whether it's the app in the field or whether you're here on the desktop, it will give you all of the current weather conditions for the area that you're in. So, for example, as it's loading here, it's loading into the San Francisco area. Let's see if it'll come into my area. So right now it's telling us that it's 65 degrees in the area of Oracle Park of San Francisco. So we do have pretty much live up-to-date weather for wherever you're at, and that includes wind and so forth. If I click right here. So you would also be able to see this in the field if you were looking at air control via your iPad or your tablet. You would also see it in Air Control, your mission execution tool. So it would also show you the weather as well.
And there's a question about, can you access LANs within the platform for flight approval around airports?
Yes, so it's right here. So if we are in Kittyhawk, whether we're in the field or whether we're here, you have the option to get a LANs authorization. So let's zoom out a little bit here. I'm not in my backyard, but I'm in the company backyard. So if we want to get a LANs authorization, it's going to, again, you're working from something that may not have GPS, like a desktop in this case. So it's giving me a rough area. But say I wanted to create a boundary and maybe I want to adjust it a little bit and say I want to fly in this area. Let me see if my boundaries are on. Let's see. We've got a bunch of different map layers, including different map layers for LANs, controlled airspace, so forth. It looks like I am outside the grid here, which is it just blows my mind that San Francisco downtown is outside the grid. But we'll go ahead and go with that. So if I want to apply for an authorization, say I want to fly at 100 feet, say it's not available for this area. Let's go over here, closer to the airport. So the airport's down in this direction. I'll drop myself in the Lance grid. Catch up to me. So we're down here in this area. It's telling me I'm eligible for up to 400 feet approval. So say I want 200. I want to take off today. I'm going to give it a little bit of time, push it out a little bit. So we'll say 205. I want to be up in the air for 30 minutes. Select next. Going to ask me a couple of things. One, it's going to tell me I'm eligible for auto approval so I can proceed. I'm near San Francisco Airport. I'm in Class B airspace. And if I select next, it's going to ask me a few questions. Are you a 107 pilot? Are you aware of TFRs? Are you responsible for operating? Blah, blah, blah. If you hit agree and submit, there's my authorization. So we have an authorization for that area for 5 minutes from now for 30 minutes. Now, one of the nice things about Lance 4.0 is that we also have now the ability to edit that rather than just get rid of it. So, oops, I did something wrong. I need to edit this. I can select this edit button, make the adjustments, and then resubmit it. In this case, I don't need it, even though I have my authorization. Now, it is also tied to my cell phone, so it did come up on my cell phone that I have this authorization as well, because typically when you're in the field, that's what you're going to have. But let's go ahead and say I don't need that. I'll go ahead and cancel it, and that way I am not clogging up the FAA's system. So yes, we have that ability.
And I just shared a video on the chat that demonstrates the new features in Lance 4.0. So I think for the sake of time, we'll take maybe one more question, and then I'll put your email, Eric, in the chat in case anybody has any further questions. So the final question is, will this detect other drones in the area or detect conflicting flight plans from other software or platforms?
So not at this point. Are we technologically capable of doing it? Yes. But there are two issues here. One, we're an enterprise platform that is secure unto itself for whoever is within that enterprise. So if I am Utah DOT, the only people I'm going to be looking at within my platform is my pilots. So I can see them, and that would show up kind of in our streaming function here. So if I had 5 folks that had launched their drones, I would see them listed 1 through 5 up here, and I would see them listed 1 through 5 across the region that they're flying in. So that's my detectability. I can see them. Could I technically see other ones? Yes, but that brings in a problem of security. All of a sudden, if everybody has access to this, we don't have that level of security that we've built for our clients. Is the capability there? Yes. Is the FAA ready for it? Maybe not. So that's the challenge. Can it be done? Yes. Are we doing it? No. But a time is coming, certainly, and we can figure all that out, that we'll do that. But right now, it's only for internal, so it's within your organization. If you're a big company like Michael Baker and you have 40 drones in the air, you'll be able to see them all. But the guy flying over in the Cessna 170, no, it's not built in there. We could add a feature like we could pair up with like a flight aware so that you could see that, but it's not necessarily notifying that small pilot, in an ADS-B type format, that we're there. So not yet.
Great. Okay, well, I think that's all the questions we have time for. So I just posted Eric's email in the chat, and we will be sending the live recording of this session via email to all the attendees. So thank you, Eric, for your time, and thanks for everybody for joining. You have a good rest of your day.
Yes, thank you very much, everybody, for joining us. And again, email if you have any questions. I'd be more than happy to help out.